Okay, so in a previous lab, we looked at very basic metadata handling by Synapse pipelines. You know, how we can loop over files in a folder, okay? Now, that's not enterprise grade, right? Because it's not going to have what we call the FAT, lineage, logging, auditing, you know, all that kind of type of stuff. And it's not going to have the extensibility to be used in an enterprise environment. So let's look at what would be usable in an enterprise environment, and indeed what we do use in an enterprise environment, right? So if we open this SQL project here, we can open labs 4, right? And in there, we've already used the SQL project in the previous lab, 4.1, to create a starter data warehouse. So what we got is a data warehouse that doesn't really have that many tables. It's just got metadata tables. This config schema, we're going to soft code the business rules on how to extract, transform, and load the data warehouse. Okay, so first thing I'm going to do is I'm going to empty down the configuration, right? So if we run this first block of code, it's going to empty the configuration. Now, the metadata tables will look something like this, right? There's a configurations table with one row per configuration element, endpoint as we call it. In this case, it's only really the data lake that we're reading from. That table's only going to have one real kind of row in it, right? We have row per data source. So a data source is a unique list of files that we're going to import. So it could be CSV reference files, Excel kind of business rules, supply chain files, you know, something that has a shared folder structure. It might be a root folder and there's a couple of subfolders off them. It could just be a whole data source, right? And then the readers are the individual files, or we could use a file mask to say every file in this particular location. And then we achieve dynamic orchestration by assigning this thing called a package group to readers. So we say, well, this group of files is one orchestration. So my supply chain is this group of files, my finance is that group of files, and there could be a superset type thing where some files are common to multiple package groups. So that's just how we handle orchestration, right? So now that, so I've blanked all of the tables. So what should happen is I've now got an empty data warehouse. Okay, so I don't have any of the I don't have any fact tables, no dimension tables. You know, there's no real kind of work done, right? So what I'm going to do is the first thing I'm going to do is insert a row into the configuration table. And this just has the name of the kind of data lake. So when I'm doing copy into commands, it knows how to construct that sort of T-SQL, right? So I run that, done. I'm going to insert the kind of data sources. So there's 3 sources of data source I've got here. I've got reference files, transactional files, you know, my financial kind of transactions, and I've got some Excel files that just contain business rules. So I run that. I've now got this table populated, data sources. So that's just metadata. So I'm soft coding a description of the files to be loaded. And this is an important one, data readers. Okay. So what I'm doing here is I'm effectively soft coding a description of each extract. Okay. I'm not letting it discover for itself. I'm putting a row in and say, yep, I want to import this file. This is it in, and there's a couple of extra bits. Like, say, for example, I'm loading dates. I'm passing it a parameter on what the date format is, because it might have a date string that could be day, month, year, or it could be a US file that's kind of month, day, year, right? So if it's a CSV file, I might pass it to say, what is the carriage return line fee, or what's special about this file that's got to be processed in a different way. So any business rules that we can pass to the ETL, whether that's in DB or in ADF, will go into this kind of table. And what we'll end up with is here. So we've got one row per source. Okay. Notice that we can choose to supply the SQL to create the table, or we can choose for it to dynamically create the table. And this is the choice we have depending on how agile we want to go. If we want maximum design efficiency and agility, we won't even bother specifying a schema and just create its own schema. The problem is if you're reading from a CSV, everything's going to be a varchar 4000, right? So, you know, there's some performance opportunities by tightening the kind of data types, right? So I'm lazy here. I've just tightened the date to kind of make it a date because it makes the sort of processing a bit easier, right? That's that. There's then a bit of miscellaneous information like, package groups. So we talked about dynamic orchestration. What sort of source types am I supporting? So we're supporting Excel, CSV, JSON, and Synapse, but we could have, Excel, Parquet, there's lots of different ones. A couple of settings, different methods. So CSV files, for example, have 3 different kind of methods of extracting them. We can use the bulk method that we just call kind of basic CSV, polybase, or copy, right? So our attitude is we don't pick one method, we support them all so that you can flick a switch to change the behavior between that. And then more information on the dynamic orchestration. So when I load the package group of DIM Finance, it will load files 1, 2, 3, 4, 5, 6. When I just load transactions, it will just load 7 as an example. Let's run that. Done. Let's think about it. There you go. That's all my metadata loaded. So now that I've loaded all of my kind of metadata, I've soft coded the business rules that described how the entire extract phase, and this could be thousands of files, right? It's not just these, it's going to be done from my data warehouse, right? And then we wrap, so there's a stored procedure then that takes those rules and dynamically creates the T-SQL. So when I say we're using stored procedures, I mean there's the one stored procedure, but it's black box, right? As in, we don't write stored procedure code for every single object. We just reuse the same stored procedure on every single project. So reader extract, right? I just pass it a parameter of the name of the file, and there's optional parameters if I know the ID or the lineage key that I want to attach that to, right? So I'm just going to run it naively, just without any special settings. And it will now go to the data lake, extract the file. Okay, hopefully. Might take a while to warm up. There you go. And now what we see is this has kind of loaded. Took about sort of 29 kind of seconds, which seems a bit slow, right? And what it's done is it's dynamically created the staging table, and it's also and then copied into, right? Now, if I was to run that a second time, it would probably realize that the kind of table was already created, and it would now only do a copy into without creating that file. Okay, so let's just run that a second time. Hopefully it doesn't take 29 seconds. No, take it 12 seconds. Now it's just doing a truncate and a copy into. Okay, now we talked about the design principle of robustness, right? I'm not sure I quite got the message of. So what I spoke about robustness, say for example, I go to my SQL pool and someone accidentally deletes a table, right? So let's accidentally delete my staging table. Gone. The next time it runs extract, it will detect that the table isn't there, and it will switch its algorithm from a insert statement into a create statement. There you go. So it's now going to issue a create statement. Okay. Notice it's not using a CTAS because copy into is not compatible with a CTAS. That's kind of why it's not doing that. Okay, so now wrapping. Let's talk about the wrapping. It's not only a stored procedure to just generate these commands. It's also then going to do the performance login, the lineage, the metadata control, and a few other bits and pieces. So let's show you an example of that. If I go to the next section here, login and lineage. So as it's run, it's put an entry into 3 log tables. The execution log is for the entire orchestration, and then 1 row in extract log for every file imported. And then the request log, I'm going to take the request DMV out of the SQL pool and permanently store it as so that we can got an audit trail of exactly what command was run, how much CPU. So here's my 3 kind of logging custom login tables, and this is on top of the platform login, because obviously Azure is going to give me the log analytics on what it's captured, right? So my extract log is what we use most, because here I've now got a lineage key, which object was kind of loaded, and all of the information on where it came from, the internal request ID, how many bytes, total time it took to actually run the copy command, and so forth. And in the request log, I've got the actual SQL statement that was run, what resource class, what important, you know, all of the internal information, if there's any weights on it, and the total elapsed time and stuff like that, right? So that's quite handy. Lineage then is when I query the table now, I see the source table has an extra column added on it that ties back to the log, okay? So that as that key flows through the kind of data warehouse, I can now track that back to an exact file that was loaded at an exact point in time. So that's basically data lineage, right? The SQL pool itself has got a bunch of DMVs, right? So these are the most common ones that we use in performance tuning. Now, we don't tend to type these in directly because they're quite wordy and there's lots of things, but there's a link there on kind of what they are. So what we've done is we've created a view called requests that aggregates all these up. So there's one row per request, but then it shows you a summary of the request steps. So when I run that, SP who is active shows me what's currently running, and SP who was active obviously shows me what was running, right? So I can see here the request and the internal command that was run, okay? And then the various steps of the execution plan, it will summarize me to say, well, there was so many seconds spent at that part, so many seconds at that part, right? So I can see that, you know, if it's creating a table, how much time was spent creating the table versus populating the table versus conditional logic, say, right? Now, the real action comes in this is when we're performance tuning, spotting data movements, you know, broadcasts and shuffles are your two things you're commonly looking for, right? So that's an example of there. Now, the other highly recommended form of monitoring, Query Store. Okay, so Query Store is a feature that was recently introduced into SQL pools. I'm just going to turn it on. So this is, and it's turned off by default, right? And what this will do is it will capture all the plans and all the SQL statements. The difference between Query Store and the internal DMVs is that Query Store is persistent. So as you pause and stop, it's going to give you a permanent record of your queries and what plans, and you can find stuff like if a query has a regressed plan where it had a good plan and it finished quite quickly, and then suddenly the exact same statement suddenly started going slow, you can actually capture the plans and compare them and find those regressions. And there's a very rich ecosystem of queries to help you find that. Okay, unfortunately, the implementation of Query Store in SQL Pool is not as advanced as in SQLDB, so there's no GUI or Management Studio add-on or anything like that, but you can certainly query it with sample queries here. So here's a sample query just to say, show me the queries, what the text was, what their average duration was, and so forth. So pretty much the first thing that we would do if we had a customer that was having performance problems, you know, and it was a nightly batch load, is turn on Query Store, right? Great program. Now, let's chat about extensibility, right? So we talked about a few other design principles, right? Extensibility. What happens if we change our mind on the design? Do we have to go back and recode the whole solution, or can we dynamically change how things happen without having to code? So as an example, we're using copy into, right? Say for example, we decide to use Polybase, right? Or say for example, they change the SQL dedicated pool and the sort of technology they're using on serverless, OpenRowset, is now available. And they're like, hey, you can use this. Can we switch our entire project to use that new approach, or is it like, oh, that's way too expensive to do that, right? So as an example, I can go to data source and I can add a new extract method that produces a different template, like different T-SQL, right? So in this case, I'm going to use Polybase. and I'm going to specify the external file format just for my transactions. So I'm going to say you were using copy into, but now I want you to use Polybase. Oh. Can't drop table because it's already there. Okay, I'm just going to comment out that bit because it's trying to drop the table that doesn't exist. What? Whoops. So I'm now going to execute that, and what should happen is it's going to import that entire table, but it's now going to use Polybase. Let's let that run. See, it's creating a table, create external table. That's a Polybase command, and it's inserting that into there. Now notice it didn't use a CTAS because it's not always compatible to use a CTAS under certain conditions. I think if you've got these extra keys or identity columns, there's a few ifs and buts on kind of CTASs. Although they are a preferred way, there's not that much difference between a CTAS and an insert into, especially on staging tables, right? So that's an example of we're using Polybase to load. But what if we change our mind? Say, well, actually, I want to use, that took 18 seconds. I want to switch it back to use a copy command. Let's load that same thing. And it's now going to use a copy command. So it's no longer using Polybase. So how long does that take to load? Okay, that took it 13 seconds. Okay, now there's actually less commands because it didn't have to create the kind of table, so it's not a fair comparison. But we've gone for quite large sets of data and found that we prefer the copy into method ourselves. Okay, now I could, if I wanted to, I could say, hey, I don't want to use either copy into or Polybase. I want to use the ADF bulk method, right? So it's going to be a SQL command, and I'm not using an InDB technology. All right. Now I'm not going to do that because we're quite kind of happy with that, right? That's that. Now let's look at orchestration. Now that's only doing one file. I'm going to do the entire data warehouse, extract it in one go, right? So what I can do is we can write. There's a stored procedure that says for a particular package group, give me all of the files that I would have to extract to do that package group. Okay, I'm just going to run that. So this extract objects tells me all the objects that I would need to extract for a particular package group. Okay, so I see that for the dimensions I've got 1, 2, 3, 4, 6, and for the transactions I got 1. Right, and then I can run a Synapse pipeline to actually do that. Right. So here's an example of a Synapse pipeline with dynamic orchestration. I'm just going to run that. Go Synapse Analytics, Bob, Home Studio. My extract controller. Okay, so what I'm doing here is I'm doing a bit of lineage and logging, which is going to be quite expensive if run through the pipeline because it's only a stored procedure that's inserting one row to say I've started, but it's going to take that couple of seconds to go through the kind of job mechanism. I'm going to enumerate all the extract objects, and then this is where the orchestration comes in. I'm going to loop through all of the files and do them all in parallel. So I'll do all the extracts in parallel. Now, if it was a load controller, I could sequence them to say, I'll do these ones, and then that one, and then that one, so I can take care of any dependencies and make sure that everything happens in the right order, right? So I can choose to run this now, right? So I'm going to click run. I'm just going to run it in debug mode, okay? That's running away. that's in progress. Now that's started to, so it's enumerating the work, it's starting to extract the files, and the extract worker is now hopefully going to start extracting all the files. Oh, I forgot what parameters did I type. Oh, I'm just doing all the dimensions. Okay, that's good. Okay, so it's working away there. Now, because I'm running this in the debug mode, it's only doing the files one at a time. Obviously, if it's fired from a trigger, it would be able to use the parallelism to kind of do them all at once, right? But that's one of the perils of doing stuff in debug mode. That's finished. I've now finished my extract phase, and I've got my logging, my lineage, and all my fat that comes with that. Right? Ah, thanks. I'll be out in a sec.